I just want to kind of do a quick summary again of our formulas. And I'm just going to do this over and over and over again because a lot of you need this repetition as a learning tool. And some of you need to be doing this repetition on your own as a learning tool. We have three basic formulas. We have distance, midpoint, and slope. These are the three basic formulas we use whenever we have 2 points. Distance formula will tell us length. So in turn, that tells us if segments are congruent. Okay? So if I need to know if segments are congruent, I have to use distance formula. Slope and midpoint will never tell me if they're congruent or not. It's a very common mistake for me to say, show the segments are congruent, and people measure their slopes. Slopes won't do that for me. The only way to show congruence is through distance formula. So if we want to prove that segments are congruent in the coordinate plane, we need to use distance formula, which is x1 minus x2 squared plus y1 minus y2 squared. Board's a little slow today. Something must be being a memory hog. Midpoint formula, here's a shocker, tells us the coordinates of the midpoint. It's kind of fun. Right now, it appears later. Okay? That's what it tells us. It doesn't tell us anything about length. It doesn't tell us anything about parallel. It just tells us where's the middle of the segment. And it always returns coordinates. And the formula is x1 plus x2 over 2, y1 plus y2 over 2. It's the only one that uses a plus, and we do not have any, it's coordinates. We've got this comma in the middle here. That's important. It's returning coordinates, not a single number like distance formula, which gives the length. It gives us coordinates, an xy coordinate for the center, for the midpoint of that segment. Yes?
Can you put the y first and then the x, or does it matter?
It doesn't matter. As long as you got the x's together and the y's together, since we're squaring and adding, that really doesn't matter as much. Okay? Slope formula tells us parallel, or steepness actually, and we use to measure parallel if lines are parallel or perpendicular. So if I need to determine if two lines are parallel or perpendicular, midpoint isn't going to do that for me. Distance won't tell me parallel or perpendicular. Distance will tell me congruence. Parallel or perpendicular is going to come from slope. And the slope formula is right there. And we use m to represent the slope. So that's a little bit of a review. Again, just to review where these things are coming from and how we're going to use them in the coordinate plane. We will be using all of them, and you need to know when to use which formula. If I give you points in the coordinate plane and I say, are these lines perpendicular or parallel, you're going to have to use slope to determine that. All right? People need to be sitting up, heads up. Let's go. You're going to need to know parallel, perpendicular. I need to use the slope formula. If you have to find the length, you have to prove things are congruent, you're going to have to know how to use distance formula in the coordinate plane. And don't bother coming up to me during a test and saying, it says show lines are parallel. Which formula should I use? That's what you need to know. And then you need to know the formula and how to use it. So again, we see how geometry is so very different from algebra. It's about picking the right piece to the puzzle each time. Every problem's like a puzzle, and you have to know how to put it together. And it's one of the things that's so challenging about geometry is you got to know what to use when. It's not a system like algebra where we just always do the same thing. It's like, gee, here are 2 points. There are a whole bunch of things I could do with them. Which one am I being asked to do? Which formula do I use? And then we need to use it correctly. So there's many decisions that take place even before you start using a formula. So don't mix up slope and distance formula. Distance shows congruence, slope shows parallel. Length and parallel are completely separate things. Parallel has to do with the steepness of the line. Congruence has to do with length. I can have parallel lines that are not congruent. I can have congruent lines that are clearly not parallel. I mean, if I have 2 segments here that are both this long, and they're like right here, are they going to be parallel? No. Okay? Congruence has nothing to do with parallel. Completely different idea. You have to know which one to use when. That's really going to be important. Now, what we haven't talked about a lot is perpendicular, and today that's what we're going to do. We're going to discuss perpendicular lines. And we have a short book assignment today, not super long. We have several different theorems about perpendicular lines, and I'm going to work through them here. We're going to work through what these theorems are. These are the rules for perpendicular lines. We're going to draw pictures. We're going to show you how note cards should be set up for this. Again, I do not want you wasting your time on note cards by doing them incorrectly. I do not want to see note cards that say, that's the front of my card, and then these words on the back. That's a waste of your time, and I will not have you wasting your time. That's not going to help you. I'm not giving you vocab and note cards to waste your time and to have you do something that isn't going to be useful for you later on. I want you doing something that is useful, that's going to help you actually learn it. That's why we want to do the note cards a certain way. If 2 lines intersect to form a pair of congruent adjacent angles, then the lines are perpendicular. So 2 lines intersect to form a pair of congruent adjacent angles. Angle 1 is congruent to angle 2. Okay? And we'll call these lines A and B. What does that mean? A is perpendicular to B. All right? That's what it means. Angle 1 and angle 2 are congruent and adjacent. They're a linear pair of congruent angles. Now let's think about that for a second. They're a linear pair, right? Angle 1 and angle 2? Which means they have to add up to 180. And if they're congruent, that means they each have to be, which means this is what kind of an angle? Right angle, and right angles formed by perpendicular lines. Now, angles are right, lines are perpendicular. There's no such thing as a perpendicular angle. All right? They kind of go together. Right angles and perpendicular do go together. They're like brothers or something like that, but they're not the same thing. They're related, but they aren't the same. Perpendicular lines form right angles, and right angles are formed by perpendicular lines. That's fine. So that would be a note card maybe for that. If 2 lines are perpendicular, then they intersect to form 4 right angles. So, this is a little bit trickier maybe to draw on a note card, but I'll figure something out. So we'll call it A and B again, lines A and B. A is perpendicular to B. We're given that. If 2 lines are perpendicular, then backside, angle 1, angle 2, angle 3, and angle 4 are all right angles. Ah, rats. They were supposed to have taken care of that. It did not work. Okay. If two sides of two acute angles are perpendicular, the angles are complementary. Okay? So we have acute adjacent angles. Okay? They aren't necessarily congruent, but they are adjacent. And I'll show you a capital letter here. And AB is perpendicular to AC. They're acute, they're adjacent, then the angles are complementary. Then the measure of angle ABC, or BA, let's point here, call it N, then M angle BAN plus M angle NAC, need an N there. I hate this not writing with me, makes it harder. Equals 90. Complementary adds up to 90. That's what we're saying in that picture. Now, it is important that they are acute adjacent angles. Because we could actually do it with two obtuse ones too, but then the angles wouldn't be complementary, they actually add up to 270, which we aren't doing angles over 180 yet, so that's not very good for us. But again, it's pretty obvious if these two, if AB and AC are perpendicular, of course it's going to have to be a right angle, which means those angles are going to have to add up to 90. What else would they add up to? It would make no sense to be anything else. If a transversal is perpendicular to one of two parallel lines, it's perpendicular to the second line as well. I have two parallel lines and a transversal. It is perpendicular to one, call this line A, this line L, this line N, and this line N. Okay? Actually, we only need perpendicular to one line. A is perpendicular to L, L is parallel to N. How would I know that A is also perpendicular to N? Yeah.
Is L and N a parallel?
L and N are parallel. What kind of angle pair would I have between this angle here, this angle 1, and that angle 2? What would that angle pair be?
Consecutive?
No. Starts with the right letter. Corresponding angles. And if lines are parallel and crossed by transversal, the corresponding angles must be congruent, right? So if this is a 90-degree angle, this must also be a, which means if that's a 90-degree angle, these two lines are perpendicular. Okay? I could have also put, for that matter, I could have put angle 2 out here, and we'd have alternate exterior and still get the same result, right? Don't forget your angle pair names. They still are necessary. We still are going to be working with them. In a plane, if two lines are perpendicular to the same transversal, then the lines must be parallel. All right? So again, we have two lines that are perpendicular to the same transversal. Okay, so here, A and B are both perpendicular to N. N. That's given. The conclusion would be A is parallel to B. Why would they have to be parallel? Well, when those lines intersect, what do we get? What you doing? Okay. Looks like we were playing a little game there.
No.
Okay. Okay. Stick with it. And don't switch off it the second I walk over. It looks awful suspicious, you know. Okay. Okay. So A is parallel to B. That's my conclusion. And again, why? It's pretty straightforward. We know if these two lines are parallel. How many right angles do I have here? 4. All of them are right angles, right? And these are all right angles too, right? So that means any pair of corresponding angles or alternate interior angles or whatever we want are congruent. So I can use any of those inverse theorems to prove those lines are parallel. Any of those inverse theorems to prove those lines are parallel, because all I have to do is find one pair of corresponding angles that's congruent, and that proves that those lines are parallel. Since everything's 90, every pair of corresponding angles is congruent. Or if you prefer alternate interiors, I could use the alternate interiors are congruent. A pair here, here, and here. We could say those are congruent too, because they're both 90 as well. So we could use alternate interior angles converse. Guys, let's keep our heads up, pay attention. I realize this may not be the most exciting thing ever for you. I understand this is kind of dry stuff. But you gotta suck it up and stick it out, okay? You gotta pay attention. One thing we're going to deal with a little bit, not a whole lot, but it is going to come into play a little bit later, is measuring the distance from a point to a line. If I have a point over here, call that point P, and I have a line here, we'll call it line L, and I want to know how far away is the point from the line. How do I measure that distance? Do I go vertical? Do I find the vertical distance? Maybe I do the horizontal distance? Or do I find the right angle distance, if I try to find a right angle between them? Which do you think is the best choice for finding the distance between a point and a line? How do we determine that? Math. Math is how we do it. That's an incredibly insightful answer. Can we maybe be a little more specific? Okay. Geometry. Well, good. Okay, we're getting a little more specific. What do you think? Okay, but I'm not in the coordinate plane necessarily right now. And how would I know which distance formula to choose? Would I choose the distance between P and this point right where the blue line and stuff intersect? Would I choose this distance? Or would I choose that distance? Which distance would be the distance between the point and the line? Because any of them could be the distance. Which one am I going to choose? Yeah. Why? Okay, you're right. You are correct. It is the red one. Okay? Because it's the shortest distance. Okay? The shortest distance is always with a right angle to the line. All right? So it forms a right angle. Why? Because any of these longer distances, if I think of these kind of like a pendulum, guess what? It could be over, that distance is over here and down here, isn't it? Yeah. Okay? There are multiple places. The right angle distance, it only just touches in one spot. Other than that, it wouldn't. That's the only spot it touches. It's the shortest distance between the point and the line. So when we are finding the distance between a point and a line, we always take the right angle distance, the angle that is the line that is perpendicular to my given line, because that is the shortest possible distance. All right, we see this a lot in problems where we're like burying telephone cable or something like that. And you know what is the shortest distance if you have a point of access in the house. What's the shortest distance to get it to the street? Okay? Well, of course, a straight line, but these are all straight lines. I mean, if this is my house and this is my street, should I put it up here? Should I put it down here? Should I put it right here? Obviously, the shortest distance is the right angle one, isn't it? Okay? So if I was burying cable, that's what we'd want. We want that shortest distance. Or if I'm swimming out here, if this is the ocean and this is the shore, all right, and I need to get the shore quick because there are sharks suddenly surrounding me. Or alligators, very hungry alligators. Or maybe barracudas, I don't know. Well, maybe someone flushed something down a toilet and now it's going to kill us all. Okay, their little pet. Freshwater shark, yes. Okay. Which line are you going to take to the shore? Obviously, you want to get the shortest distance, don't you? Which would be the right angle distance. You don't want to run at it diagonally. No, you pretty much do it instinctively. When swimming from one? No, you just want to swim as fast as you possibly can because they're going to be way faster in the water than you are.
Well, you could go in like burly, not like zigzag.
I'll remember that. That's if you're running from somebody who's shooting at you. Run in a serpentine fashion. So, don't run in straight lines. If you're trying to get away from an alligator in the water, just go. Get out of the water as fast as you can, because they're a better swimmer. They're a much better swimmer than you are.
I don't know how to swim.
Then you're just going to be eaten by the alligator, I guess.
I just don't go in water.
There you go. You never bathe, huh? That's a shame. Okay. All right, how do we use this stuff? Again, we're going to use this stuff the same way we have been using it to set up and solve equations. It's just that now we're going to have more equations because perpendicular is our kind of theme. A lot of our equations are going to add up and be set equal to 90 instead of 180 because we have the right angle. So I have perpendicular lines, and I have these two. Now again, this is exactly where we were on our last quiz, where people had difficulty, where people had a tendency to look at that and say, oh, set them equal to each other. There's nothing there in this picture to tell you, give you any clue that those two angles would be congruent. There's no indication of that whatsoever. That would be a very bad assumption to make. But when I do see, what information am I given? I'm given that this is a right angle, perpendicular line, which means this also must be a right angle. And then I have my relation, 4x plus 10 plus 2x minus 10 is 90. So 6x is 90 divided by 6. X is 15. So now instead of just supplementary angles, which we mainly dealt with, or congruent angles, or adding up and setting equal to some arbitrary total, or whatever we're told the measure is, this is our fourth general tool, and this is adding up and setting equal to 90. So that now becomes a tool in our arsenal. We can choose to add up and set equal to 90. But again, each problem is going to rest on its own merits. You have to kind of stop, look at the picture, think about what information is given in that picture, and go from there. I could give you almost exactly the same picture. All right? With the same numbers, 4x plus 10, 2x minus 10. Almost exactly the same picture. Okay? But this time, give you this indication. Instead of the right angle symbol, I'm giving you that indication. Now, would we add them up and set them equal to 90? No, because the information we're given is different. Now I have these marks that tell me those angles are congruent. So now I say 4x plus 10 equals 2x minus 10. Now I go that way. Because even though the picture is very similar and the numbers are similar, the information we're given about the picture is different. The information here is right angle. The information here is congruent. So you have to look at, even they can look identical, but you got one little difference, and that makes all the difference in how you set up and solve the problem. Let's take a look at what the assignment is for tonight. It's mainly dealing with perpendicular, identifying which theorem's being used. Your note card should help with that a little bit. There we go. Today's Wednesday. 194, 1 through 10, 13 through 21, 29, and 30. That's really not bad, no. They're pretty quick problems, too. That's 10, 18, 20 problems. Hey, sit down, please. Okay, well, backpack stay off till the bell rings. Backpack stay on the floor till the bell rings, right?